So for my State of the Microbial Universe project, I decided to study the link between Streptococcus bovis and colorectal cancer. Why I chose this topic of study? My personal reasoning: I am a aspiring physician who has a particular interest in cancer research, given that I have lots of very close family and friends that have been impacted by the adverse effects of cancer, not just colorectal cancer. Significance: colorectal cancer is the third most common cancer across the world. It has multiple risk factors, including genetic predisposition, lifestyle, as well as other environmental factors. Studies show that Streptococcus bovis may play a role in colorectal cancer, as seen through Streptococcus bovis bacteremia. Streptococcus bovis has also been found in colorectal tumors themselves. Implications on public health and clinical practice. It's important to find a link between Streptococcus bovis and colorectal cancer to promote research into more effective screening methods, and which ultimately promotes early detection of such cancer. It also allows clinicians to identify higher-risk patients for this type of cancer and target them with educational intervention and preventative measures. The microbiology of Streptococcus bovis. Some general information: it is a gram-positive bacteria. Cell wall containing peptidoglycan, teichoic acid, and lipoteichoic acids. It is cocci-shaped, often arranged in chains or pairs. It is non-motile, meaning a lactoflagella. It is a facultative anaerobe and can grow in the presence or absence of oxygen, but prefers anaerobic conditions. It is a chemoorganotroph, deriving energy from the oxidation of organic compounds. It ferments carbohydrates such as glucose, lactose, sucrose, mannose, producing lactic acid, but cannot ferment mannitol or sorbitol. As far as it goes for the habitat in the human body, varying strains of Streptococcus are commonly found in the flora of skin, in the oral cavity, nasopharynx, respiratory tract, gastrointestinal tract, and even the urogenital tract. As far as it goes with the role in a normal healthy microbiome, there's not a lot of research into the benefits of it within your microbiome. However, research into the link between inflammatory gastrointestinal diseases and prevalence of CRC, better known as colorectal cancer, shows 10% of healthy individuals have Streptococcus bovis present within their gut microbiome. Looking at some of the mechanisms of interaction in general, chronic inflammation is identified as a significant risk in the development of colorectal cancer. Active inflammation measured histologically is associated with a 4.7-fold increase in dysplasia and risk of cancer development. In general, Streptococcus bovis found in the human GI tract promotes inflammatory responses. More specifically, researchers conducted proteomic analysis identifying 12 different proteins within Streptococcus bovis' makeup that have been found responsible for inflammatory responses in intestinal cells. Further research and experiments performed on rats that were pretreated with carcinogens showed that Streptococcus bovis proteins can promote pre-neoplastic lesions and the progression of such lesions. As it pertains to virulence factors, Streptococcus bovis possesses three key virulence factors, one being surface proteins, which facilitate attachment by recognizing adhesive proteins and components of extracellular matrix, aiding in the attachment to varying gastrointestinal cells and overall colonization. They're able to form biofilm, which is one of their virulence factors. This biofilm formation acts as a protective barrier against antimicrobial agents and immune cells, which I'll talk about a little bit more in the next slide. Implicated in hospital-acquired infections, particularly around hospital devices such as catheters, among other devices. It also has soluble cell wall antigens, which induce the activity of interleukin-8, leading to overexpression of enzymatic activity. This overexpression of enzymatic activity, in turn, leads to promotion of immunogenesis in intestinal mucosa cells. Antimicrobial resistance. So there's lots of studies out there on antimicrobial resistance, especially as it pertains to Streptococcus bovis, which have found that it is completely resistant to oxacillin, penicillin, cephalothin, and imipinin. It is susceptible against levofloxacin, gentamicin, tetracycline, and particularly susceptible against erythromycin and clindamycin, as erythromycin's resistance rate is just 2%, and clindamycin is a big fat 0%, meaning it is extremely effective in treating against Streptococcus bovis. Potentially effective but non-susceptible antibiotics include vancomycin and linezolid, with non-susceptible rates of 84.3% and 94.1%, so not super effective in that regard. Combating Streptococcus bovis and preventing colorectal cancer. In general, there's certain guidelines that are pretty standard that promote an overall healthier lifestyle, subsequently leading to reduction in colorectal cancer. Some of these factors and guidelines include regular exercise, avoiding smoking, avoiding excessive alcohol consumption, and overall just maintaining a healthy weight. There's lots of promising studies into the introduction of probiotics and how that can lead to the prevention of colorectal cancer, as it's been found to reduce harmful bacteria such as Streptococcus bovis, Salmonella, and Shigella. And it also increases it also leads to a beneficial increase in lactic acid bacterium and bifidobacteria. In such studies, probiotic consumption is associated with a tenfold reduction of fecal putrescine and 60% reduction in mutagen fecal concentration. Prebiotics, similarly, which are essentially non-digestible food ingredients that selectively stimulate growth of specific healthy bacteria in the colon and gastrointestinal tract, are considered an alternative to the introduction of probiotics when trying to prevent colorectal cancer. Some of these common prebiotics that help in the prevention are inulin, fructooligosaccharides, lactulose, resistant starch, and dietary fiber. For my AI utilization, I used primarily just Bard and ChatGPT, and had Stable Diffusion produce all my images for this presentation. Bard was particularly useful in providing articles, scientific articles more specifically, and it gave me links to those articles. It provided good citation information such as authors, journals, publication dates, and whatnot. I even gave little summaries here that kind of gave me a good idea of what I was going to be reading and prompted me to go further into summarization. ChatGPT, on the other hand, does not have access to the open internet, so I primarily used it for article summarizations. I feel like it did a really good job of breaking down some of these really hard to read scientific articles that were really long and kind of simplifying them, making them into concise bullet points, as you can see here. So I thought ChatGPT was really, really useful in that regard. Some of these helpful prompts. Here we have Bard, being very specific in what I was looking for in some of the scientific articles I was asking it to provide. Very useful. The more specific, the better. ChatGPT for summarizations. Just kind of talking to, honestly, both of these AIs like they were human. If they didn't understand you the first time, just kind of being more specific and kind of tailoring to what I thought they would be looking for. And I feel like that can be portrayed in a lot of these prompts. So yeah, overall, these are some of the prompts that I found really useful in my research. While both of these AI were essentially crucial to my study and very, very useful, very, very helpful, there were limitations of BART. The accuracy of article summaries comes into question and required me to go back and kind of redo them myself. It had trouble accurately citing articles and would provide just random author information, inaccurate titles, journals, dates, and that was not very helpful. It gave me unrelated articles. As you can see here, can you listen to an article detailing properties of Streptococcus bovis with a link to that article? Gave me one about endocrine disruption as it pertains to flame retardant chemicals. I was like, okay, whatever. And other stuff, as you can see. And it eventually reached a capacity where it would keep providing me the same articles over and over, and it seemed to reach capacity of relevant articles in which it was able to provide. As you can see, I sent it. You keep sending me the same 4 to 5 articles. Can you diversify the selection of articles provided? And I kind of just apologized and said it was still in development, still working on it. And I was like, all right, well, that essentially prompted me to do a lot more independent research and kind of utilize AI more so for summarization rather than gaining articles from it. ChatGPT also had lots of limitations. It often contradicted itself. It had told me that Streptococcus was classified within the Streptococcus genus, but had been reclassified into the Enterococcus genus. I was very confused by that, so I asked it what it meant by that, and it kind of just contradicted itself and said that they were both distinct bacterial species that belong to different genera. I was like, okay, whatever. Like that just prompted me to do more research on my own and really look into what these AIs were telling me. I was unable to provide article sources as I didn't have access to the internet, so that's ultimately why I relied on it heavily to just primarily do summarizations. It had a prompt word limit, which was not the end of the world, but it made it difficult when trying to summarize some of these really, really long articles. I couldn't just copy and paste the whole article. I had to break it up and kind of go back and forth between tabs, copying and pasting, which wasn't the end of the world, like I said, but it was definitely a little bit more tedious. Overall summary of the AIs I used, possibilities are near endless. With the vast utility of AI shown not only as it was used within this project, but as it pertains to countless other fields of study, it's been proven to be an extremely valuable resource with nearly limitless possibilities. However, with that being said, at its current state, limitations are definitely evident and should certainly be taken into account when using it. Given its constant development, though, and its advancement on what seems like a daily basis, I myself am extremely excited to see the direction that AI continues to go in. And this project definitely allowed me to see that better, which I'm really grateful for. And lastly, here are my citations. As you can see at the bottom of each citation, I have an asterisk. Those denote articles that were peer reviewed. Out of the 19 pertinent articles I was able to find that were all really valuable, 17 of the 19 were peer reviewed, as you can see here, noted by the asterisk. And yeah, that was my project. Thank you very, very much.